Hello everyone, this is Prema Halegoda. I welcome you all to this fifth session of third module, that is laser. In this session we are going to discuss about ruby laser. After this session, the students will able to explain different types of laser and also they will understand the structure and working of ruby laser. On the basis of active medium used in the laser systems, lasers are classified into several types. In those, main types of lasers are solid lasers, example ruby laser, Indiarc laser, Indiglass laser, etc. Second type, liquid lasers, example europium chelate laser. Gas lasers, examples carbon dioxide laser, helium neon laser, argon ion lasers, etc. Dye laser, rhodamine 6G laser, semiconductor lasers, examples indium phosphide laser, gallium arsenide lasers, etc. Construction of ruby laser. Typically, in ruby laser, 4 cm length and 5 mm diameter rod is used. Both the ends of the rod are highly polished and made strictly parallel. The ends are silvered in such a way that one becomes partially reflected and another end fully reflected. So this is partially reflecting end and this is fully reflecting end. The ruby rod is surrounded by the xenon flash tube which provides the pumping light to excite the chromium ions into upper energy levels. The xenon flash tube emits thousands joules of energy in few milliseconds, but only a part of that energy is utilized by the chromium ions while the rest energy heats up the apparatus. A cooling arrangement is provided to keep the experimental setup at a normal temperature. Working of ruby laser. The energy level diagram of chromium 3 plus ion, it is as shown in the diagram. The chromium ions get excitation to the higher energy level by absorbing the photon of wavelength 5600 angstrom. The excited chromium ions stay in the higher energy state H for a very short interval of time of about 10 raised to minus 8 seconds. After their lifetime, the most of the chromium 3 plus ions are de-excited from H to G, and a few of them are de-excited from H to M, that is metastable state. In the metastable state, the lifetime of the chromium ion it is 10 raised to minus 3 second. The lifetime of the chromium ion in the metastable state you just compare, it is 10 raised to 5 times greater than the lifetime of the chromium ion in the higher energy state H. Due to continuous working of a flash lamp, the chromium ions are excited to higher state H and returned to the metastable state M. After few milliseconds, the level M is more populated than the level G, and hence the desired population inversion is achieved. The state of population inversion is not a stable one. The process of spontaneous transition is very high when the excited chromium ion passes spontaneously from H to M. It emits one photon of wavelength 6943 angstrom. The photon reflects back and forth by silver ends until it stimulates an excited chromium ion which is present in the metastable state, and it emits fresh photon which is in phase with the earlier one. The process is repeated again and again until the laser beam intensity is reached to a sufficient value. When the photon beam becomes sufficiently intense, it emerges through the partially silvered end of the rod. Now, you just guess this 6943 in which region it will fall. Yes, it will fall in the visible region, and that too in the red radiation region, that is 625 to 740 nanometer. Yes, that's why the ruby laser, it is red in color. Drawbacks of ruby laser. This ruby laser requires high pumping power, and the efficiency of ruby laser is very small, and also it is a pulse laser. Uses of ruby laser. Ruby laser, it has its wide application in various fields. These are used in optical photography, and this can be used for measurement of plasma properties such as electron density and temperature, and also ruby lasers are used to remove the melanin of the skin. And one more, the ruby laser can also be used for recording of hologram that we will discuss in our next session. Based on the today's session, let us discuss some multiple choice questions. First one, the ends of the ruby rod works as A. Pumping source, B. Active medium, C. Cavity mirrors, D. Energy levels. Answer is C. In the ruby laser, one end of the ruby rod is completely polished while the other end is made partially reflecting, and hence the two ends work as the cavity mirrors. Which of the following is a three-level laser? Three-level laser. A. Nd:YAG, B. Ruby, C. Helium neon, D. Semiconductor laser. Option B is the right answer, that is ruby laser is a three-level laser. The lifetime of metastable state in a ruby laser is option A 10 raised to minus 8 second, B 10 raised to minus 6 second, C 10 raised to minus 3 second, option D 10 raised to minus 2 second. Answer is option C. The second energy level in a ruby laser is the metastable state. Its lifetime is 10 raised to minus 3 second. It is between this state and the ground state that the lasing action takes place. The pumping mechanism used in the ruby rod is option A. Optical pumping, B. Electrical pumping, C. Chemical pumping, D. Thermal pumping. Answer is option A. The ruby rod is placed inside a xenon flash lamp so as to provide sufficient amount of light to cause excitation of atoms. This kind of pumping is called optical pumping. The ruby laser beam is emitted in the form of A. Fluctuating radiation, B. Continuous spectrum, C. Pulsed output, D. Exponentially decreasing intensity. Answer is option C. The laser output observed in a ruby laser is pulsed. This is so as the flash lamp operation is pulsed, and there are spikes in the ruby laser output lasting a few milliseconds. Thank you for watching.